In today's video, we're going to look at section 10.6, where we apply the sum and difference formulas. There are two learning targets in this section. Learning target 10.6a is I can use the sum and difference formulas to evaluate trigonometric functions. And learning target 10.6b is I can use the sum and difference formulas to simplify trigonometric expressions. So first off, we need to look and see what those sum and difference formulas are. So here on the screen I've got the six different sum and difference formulas. You do not need to memorize this. It is on the sheet that I provided for you. And you will be allowed to use that sheet on both the quiz and the test. So there's the different possibilities of, say, like a sign of two things where you're adding them, or two things if you're subtracting. What this does is it allows us to get exact values now instead of just decimal answers for some of our possible angle measures. So when evaluating trig functions, what we're trying to do is we're trying to find two values, and I listed those values that we typically use. So like your 30, your 45, your 60, 90, 180, 270, and 360. So try to find two of those values that either add or subtract to be the given number. So now let's look at an example of that. So example 1 is an example of learning target 10.6a. Find the exact value of first the cosine of 15 degrees, and then second the sine of 7 pi over 12. So we're going to start with that first one, the cosine of 15. So what we're trying to do is find two values, because up to this point, if we were asked what the cosine of 15 was, we would just have to type it in our calculator and get a decimal approximation. But the directions here say find the exact value, meaning we need to leave it in radical form. So we want to use the sum and difference formulas. So we're going to find two values that either add to be 15 or subtract. So looking at that list of numbers that I gave you on the previous slide, I know that if I take 45 and I subtract 30, because those are two values on that sheet, so 45 degrees minus 30 degrees, that gives me 15. So now I have the cosine of a subtraction. And the cosine of a subtraction says that the cosine, so we'll just go back here and look at that, the cosine of, they use u's and v's, u plus v equals the cosine of the first times the cosine of the second minus the sine of the first, sine of the second. So let's apply that to here. So u plus v equals the cosine of u, cosine of v, whoops, and back here it should have been a plus sign, or a minus sign because we're subtracting, u minus v is equal to the cosine of u, cosine of v, plus the sine of u sine of v. Where our u and our v, u would be the 45 degrees and v would be the 30 degrees. So cosine of 45 minus 30, plug the 45 and 30 in. So the cosine of 45 degrees, cosine of 30 degrees, plus the sine of 45 degrees, sine of 30 degrees. Now we're going to look at the unit circle sheet to find the values of these cosines of 45, cosine of 30, sine of 45, and sine of 30. So by looking at the unit circle sheet, I see that the cosine of 45 is the square root of 2 over 2. The cosine of 30 is the square root of 3 over 2. Plus the sine of 45 is also the square root of 2 over 2. The sine of 30 is 1/2. And now I'm just going to simplify and multiply straight across. So my first term becomes the square root of 6 over 4 plus the square root of 2 over 4. They already have common denominator, so I go ahead and add them together. So we get the square root of 6 plus the square root of 2 all over 4. And there's my exact answer to the cosine of 15 degrees. So now let's look at part B, which was the sine of 7 pi over 12. And now sometimes with the radians, sometimes that's a little trickier because it's not as easy to see. Like looking at 15, I know 45 minus 30 is 15. But with the radians, sometimes it's not as easy to see that relationship between the radian equivalents to those 30, the 45, 60, 90, 180, 270, and 360. So if you want, you can convert these to degrees and then work with it from degrees. So take your 7 pi over 12, multiply by 180 over pi and get it in degrees, and then just do the problem the rest of the way in degrees. I'm going to go ahead though and finish this in radians just so you can see it in radians. So the sine of 7 pi over 12 is the same thing as the sine of pi over 3 plus pi over 4. So if I were to find common denominators, I would get a common denominator of 12, and then I'd have 3 plus 4, which gives me the 7. So now I need to use that rule for the sine of u plus v, which says that it's the sine of u cosine of v plus the sine of v times the cosine of u. So now I just plug in those values. So the sine of pi over 3 plus pi over 4 equals the sine of pi over 3 cosine of pi over 4 plus the sine of pi over 4 times the cosine of pi over 3. And now again, I just look at my unit circle sheet to finish this out. So the sine of pi over 3 is the square root of 3 over 2 times the cosine of pi over 4, which is the square root of 2 over 2, plus the sine of pi over 4 is the square root of 2 over 2. The cosine of pi over 3 is 1/2. So now again, I just go ahead and multiply those, giving me the square root of 6 over 4 plus the square root of 2 over 4. Again, common denominator, so I go ahead and add them together. Square root of 6 plus the square root of 2 all over 4. And there's my exact answer to the sine of 7 pi 12. Now notice that we do end up getting the same answer. That won't always be the case, but a lot of times because we'll be using the same basic values of 30, 45, 60, the 90, the 180, the 270, and the 360, we will get things that look very similar, sometimes maybe a subtraction sign instead of a plus sign. So know that you will get similar answers, and a lot of times you will get the same answer, but it's the process to see which formula, the sum or difference formula you used, and that you plugged everything in correctly that I'm looking for. So let's now look at another example of Learning Target 10.6a, and that is find the value or find the tangent of a minus b, given that the tangent of a is negative 7 over 24, with a being between pi over 2 and pi, and the tangent of b is 4/5 for pi b being between pi and 3 pi over 2. So when we do this, the first thing is we just need to write down what that formula says. So the tangent of a minus b is equal to the tangent of a minus the tangent of b all over 1 plus the tangent of a, tangent of b. So I'm just getting that right off of that sheet, right off of those trig identities that I gave you at the beginning of this video. And now it's just a matter of plugging those things in that they gave us up above in the directions. So tangent of A, they said, was negative 7 24ths, minus B, which is 4/5, all over 1 plus the tangent of A, so negative 7 24ths, times B, which is 4/5. So now it's just a matter of simplifying that. So when I subtract the tops, get that common denominator, I get a negative 131 over 120 And then I'm dividing that by, when I combine those, I get 23/30. So now remember, that's the same thing as saying negative 131 over 120 divided by 23/30. So then I can leave change, flip it. So 131 over 120 times 30 over 23. I can do some simplifying. 30 goes into 120 4 times and then multiply straight across. So I get 131 over 92. And there would be my exact answer for the tangent of A minus B. So for learning target A, we were evaluating these trig functions. Now we want to be able to simplify them like we've done in the previous couple sections. So we want to simplify, so we're going to use the sum and difference formulas to break apart the expression and then to simplify. So it'll have some variables in it, but then it'll also have some numbers that will help us evaluate it to make it a simpler problem. So let's look at our first example. First example of learning target 10.6b is simplify the sign of x minus 5 pi over 2. So we're going to use that sign of u minus v equals the sine of u cosine of v minus the sine of v cosine of u. So in this case, the sine of x minus 5 pi over 2 is equal to the sine of x cosine of 5 pi over 2 minus the sine of 5 pi over 2 cosine of x. So now the cosine of x and the sine of x, we can't do anything with those. So I'm going to go ahead and leave that here. But I need to figure out what like the sine of 5 pi over 2 is. Now keep in mind, to evaluate that, one of the things we can use is the fact that it is periodic. So 5 pi over 2, if I think about where that's located, one full time around is 2 pi, or in our case, because it's over 2, 4 pi over 2, which means I'm at least one full rotation and then one more half of a pi, which means I'm right back up here. So it's the same thing as pi over 2. So I can think of this as the cosine of pi over 2. Then over here, the sine of pi over 2, because those will give us the same values. Now that allows me to look at my unit circle sheet and see that the cosine of pi over 2 is 0, and that the sine of pi over 2 is 1. So then the first quantity, when I multiply by 0, sine times 0 is just 0, so it goes away, leaving me with a negative cosine of x. And there it is, then that sine of x minus 5 pi over 2 simplified down to a negative cosine of x. So let's try one more problem where we're doing some more simplifying. So learning target 10.6b. And they want us to simplify the tangent of x minus pi. So again, we're going to look at our trig formula sheet and find the tangent of u minus v, which gives us, off of that sheet, the tangent of u minus the tangent of v all over 1 plus the tangent of u tangent of v. And now I'm just going to plug those things in, because the tangent of x minus pi is the same thing as the tangent of x plus, not plus, minus the tangent of pi all over 1 plus the tangent of x tangent of pi. So now again, any that have a value, not a variable, but a value, we're going to look at our unit circle sheet. Pi is on there, and when I look up the tangent of pi, I see that it is 0, so I get the tangent of x minus 0 all over 1 plus the tangent of x times 0. So then my top becomes just the tangent of x. The bottom becomes 1 plus 0, which gives me then the tangent of x over 1 which is then just the tangent of x. So there it is in the simplified form. So in this section, we're just looking at being able to either evaluate trig functions using those basic trig or basic angles that we have, the 30, the 45, and the 60, and then sometimes the 90, the 180, the 270, and the 360, or taking and simplifying some trig expressions using these trig formulas, or the sum and difference formulas.